Do you or your shop have a Maximus 4.0 scan tool system from Matco Tools? Do your scope leads still have the twisty ties on them? We're going to talk about the basics of this scope and how to get it set up and get you up and running quickly. What's up everybody, Brian Mann here, Hands-On Auto Training. I have on loan to me a Maximus 4.0 from a local tool rep. There's a lot of shops in my neighborhood that are buying this piece of equipment and they don't know how to use the scope portion of it. So my goal here is to show you some of the quick and easy tips to get up and running. And also, I'm going to be honest with you, the first time I used this scope, I was on site at a shop working with them and I didn't know how to use it. I really didn't even understand how to click around. So we're going to cover some of the basic menu options and get you set up. We're going to work through a demonstration board just to show you some of the pros and cons of this scope. I mean, it's pretty good for what you're getting. If you have this piece of equipment, it is a powerful scope. I'll tell you that right now. It is a 100 megahertz bandwidth, I believe is what they rate this at. So that's, you know, pretty stout. It's a big number, and I'm going to show you some of the things that I think they can work on the software end of it to make it easier for us. But there's also some features that I'm impressed with that are on here. So let's go ahead and get started. Now, I do have this set up so we can actually see the live screen recording as you see here. Want you guys know so you can see that nice and clear. We can go in there and out of there, but it's more important that you guys see where my fingers are going as I navigate the menu here. So on the upper left-hand corner, there is a menu button. Right next to that's our zoom button. Next to that is basically our sample rate, how many samples and how many samples per second we're getting. So take a look at that up close. You can see we have our menu button here. And the first thing I'm going to do is put this back to the factory reset. There's these different menus here. We're going to go to user set, that's what they call it. And we're going to click on factory reset. And I'm going to hit OK. This is going to get this scope set up just like it comes out of the box for you. So as you see, we've kind of totally lost our pattern here, and that's what's going on. Now, I want you to know there's a lot of stuff on this screen, and it can be confusing. So we have our menu button here, our zoom button here. Like I said, our sample rate, our sampling is there. We have our trigger. This trigger is really interesting to take a look at. There is the trigger level menu, and I want to go ahead and scroll this up and down. You can see I'm changing my level, but also if I click on this, I'm changing the channel that we're triggering off of, which is kind of really weird. It was interesting to me, and I didn't understand that at first. So I'm going to go ahead and hit my menu button and go back to my trigger display. And I want you to see here, as I type this up and down button, over here you can see this is changing the channel that we're triggering off of, which is really interesting. So I want to be triggering this off of channel 1 for what we're doing. And also, as I said, this scope screen is kind of busy. There's a lot of stuff going on here. To turn the channels on and off, I'm going to do channel 4 and 3 on this view, and I'll do channel 2 on the zoomed in view so you can see. Each time I click on the channel icon, it does a different function. So tap on it once, it brings up this channel menu, and you can see all your different functions. We'll dive in on it when I have the screen capture closer. Tap on it again, and this channel is turned off. We're going to do the same thing with our magenta or our purple channel here, channel 3. Tap on it once, it opens up the menu. Tap on it again, it turns it off. Let's go ahead and get zoomed in here. Well, I'm going to do this with channel 2. I tap on it once. It opens up the channel menu. From here you can see we can couple this with AC or DC. We can invert the channel if we wanted to. Are we measuring voltage or current? You can select that. It gives you the different amp clamps if you're measuring current. And also we have our attenuators. And we also have our bandwidth, which is our filtering. We can have a high pass filter, low pass filter. Are we going to go ahead and turn this on to a full, which is just capturing everything? And I don't know what the 20M means. I didn't touch that. I'll be the first one to tell you. If I don't know about it, I'll tell you I don't know. But we're going to go ahead and turn channel 2 off here. Now here's our channel 1, and taking a look at this, I want you to know that we don't actually have like a voltage that we can choose from. So this is our channel 1, our voltage menu right here. You click on the lower icon to decrease the pattern, which is actually increasing the voltage. So if you need the pattern smaller, click on the smaller icon. If you need the pattern larger, click on the larger icon. You can also drag this little arrow over here. You can drag this up and down to get the pattern on your screen. Now from the get-go, out of the box here, I will tell you that this scope is set up on a really fast setting. If you look down on the bottom middle of this screen, you'll see we have or 1 microsecond per division. This scope is counting 1 microsecond per division is basically what we're capturing. So this is a super duper fast capture. We don't need it this fast for most instances. I mean, really not necessary. So what we're going to do here is take a look. We're going to go ahead and hit this big button, and as you see, it'll zoom in even more, and then we can hit the smaller button, and we're actually putting more time per division. So I'm just increasing the time per division, and all of a sudden you're starting to see a pattern come up on the screen. And I'm going to go ahead also and click up here and actually click down and change my voltage so I can get the whole pattern. So now we have a buffer that's getting filled up, and we don't have a triggered event. The one thing I see technicians doing all the time is they're not understanding triggering. If you get your scope on, your leads hooked up, and you don't have a pattern coming up, it's really important to make sure your triggering is on. I'm going to go ahead and walk through the triggers really quickly here on this scope. So taking a look here on the scope, our main menu is where we can get stuff set up here for our trigger. We can choose which channel we want to trigger on. And right now we want to trigger on channel 1. We can also do a couple other more advanced features, but we have our common button. We can go auto or normal. If we go to normal trigger level, or normal triggering, this is only going to display a pattern if our trigger criteria is met. So I'm not changing anything besides dropping down my trigger menu on the right-hand side of the screen here. Let me show you that. So I'm just dragging this up and down. When I put it up, we have a pattern. If I drag this out of the criteria or out of the scope capture, out of our actual signal level, we do not get a pattern. This is where technicians get screwed up all the time. I'm telling you guys, make sure that you put your trigger to auto. If you don't know what you're doing, put the trigger to auto. If I click on the auto button, you're going to go ahead and see we have a pattern. This pattern is drifting across the screen a little bit, and that's okay. You can kind of see that moving across the screen. We're going to move this level up, and you can see we have a capture happening again. The one thing I found very confusing about this scope, or about the triggering, was if I click on this trigger menu and I go to, I'll go back to my trigger menu, and we're on common, our edge, we can watch what happens if I drag this up and down right here. I want you to see if I drag this up and down, this is our level here, but if I so much as touch on the bottom, it's changing the channel. So watch this. I'm going to zoom back in there so you guys can see. I am changing the channel that we're triggering on by just touching this. This is kind of confusing to me. I was bumping it and I didn't know what I was doing when I was messing around with it. So I want to be on channel 1, and we can adjust our level here. So that's what we're doing. We can also go to our common, and I believe, let me see here, our edge is here. We can go on a rising edge, falling edge. As I click on this, I want you to see changing this, changes this scope capture view up here. It's telling you how you're triggering up there on the window. So that's nice. We can be on a rising edge. That's fine. But we have a pattern displayed. And once again, to make the pattern larger or smaller, let me go ahead and hit the stop button. That is down in the other corner down here, our run and stop. So we're running, we're capturing, hit the stop, we're not capturing. I can go ahead and actually increase and decrease the scaling, vertical scaling right now through this menu. So that's pretty cool. Up and down on the right hand side there for that channel, we can increase and decrease that. Something else that's important, let me go ahead and zoom back out of this. Something else important here is if we turn another channel on, I'm going to turn channel 2 on by clicking on channel 2. I can actually move channel 1. You see, I'm just moving the screen up and down, but I have channel 2 on. To select different channels, you actually have to click on this button right down here, right next to our time base, or our time per division. You click on this button. Now I can select which channel I want to use from right here. I select channel 1 or 2. So I'm going to select channel 2. And then now when I move the screen, I'm actually moving my channel 2. And I don't know where my channel 2 is. Let's hit the record button. I didn't have it on. So we should have channel 2 coming in here. There's our channel 2. I can move this up and down. You see, that's what's going on. So you select which channel you want to move by this menu down here, channel 1, channel 2. It's very important to understand that, because if you don't, you'll be lost like I was, and I was monkeying around trying to figure out how to use it. So that is the basics about the trigger and some of the navigation here. Let's go ahead and talk about sample rate and or what a bad sample rate looks like. Because if you don't have the scope set up properly, if you have a very low sample rate, your signal's going to be not good. So I'm going to go ahead back in here to the tool. I'm going to hit the run button. So I'm going to go ahead and hit the run. And I'm also going to turn off channel 2 by double clicking on it. So we just have channel 1 here. And we have our scope set up for 50 milliseconds of division. That's what we're seeing there. So I'm happy with that. That's cool. But if I hit the stop button, I want you to see if I hit the zoom button now, right next to our menu button, this is all that we captured. We have a nice buffer filled up. That's cool. But let's go ahead and zoom in and see what this looks like. We're going to go ahead and use these buttons here to zoom in and zoom out. So if I zoom in nice and tight, I'm going to drag this pattern over here. I want you guys to see that we have a clean signal. I mean, I'm talking way far zoomed in. This is awesome. If you wanted to measure the amount of time that this was on, we can go ahead and click on our cursor menu up here. There are 3 different cursor menu options we have. The first one here is our cursor to measure our signal. This is our signal up and down. So there's actually this little signal level here. I can grab this one and I can measure this, and I'm going to grab this one and go here. And you see the tool right here is also measuring that. So Y1 is at 3.86 volts and Y2 is at 71 millivolts. So that's cool. To measure our time, we can actually go ahead and click on the cursor 2 button. Now we have this out. So I moved the pattern. I want to grab the ruler, and I can move this ruler here, and I'm going to grab my other ruler and put it over here. And you can see here now it's telling us the time is 54 microseconds is what we're measuring there. And the frequency, it does that for us. Now I don't like the fact that as I move the pattern, the rulers don't stay there. I have to move the ruler back to get this measured out again. And that's kind of a little quirk in it, but it's okay. It's not anything a deal breaker in my opinion. But something really cool is the third cursor option. I can go ahead and turn this on. Check this out. We actually have our phase rulers, if you will. We can measure degrees. We can measure and mark degrees. So let's go ahead and I'm going to zoom out just a little bit. And I want to go ahead to the point where I have, like, let's say 1 revolution of this crankshaft. This is a 58 tooth crankshaft right here. Let me go ahead and move this pattern. Actually, I got to zoom out more. I'm zooming the wrong way. Got to get this here going. So I have 1 revolution of this crankshaft on the screen here between the missing teeth of the pattern. So it's really good to understand. So this would be 1 full crankshaft revolution right here. I can actually grab our rotation ruler, and I should be able to grab this, and where to go? Here's a 360. I'm going to mark this out here, and I'm going to grab the other end of it, is right here, and we can actually mark out 360 degrees of rotation. If I can make this stay still. It's a little funky to grab these rulers, but it's not bad. It's pretty cool. So we have marked out here 360 degrees of our crankshaft rotation. Now if I put my other cursor on here, I'm curious to see if I turn on cursor 2, will that measure in degrees as well? And I don't believe it will. So we're not able to measure out degrees from here by moving this cursor, but that's okay. But it's really neat that they actually went ahead and have the function of the rotation or phase rulers on here. Very cool. Thumbs up Matco on that, or Handtech, or whoever makes a scope. I like that function. That's the cursor functions. The next important thing that I want to talk about is our sample rate. This scope has a pretty powerful processor or whatever is inside of it to make it go. I'm going to demonstrate to you how we can get a 20-second to capture and still have a pretty darn clean signal on this crankshaft sensor. The fastest pulse on this is around 40-something microseconds pulse down. So let's go ahead and take a look back at the scope here. I want to go ahead and change my sample ring. Let's go to 1 second of division. So we have 10 seconds of time on the screen. Guys, we're filling up our buffer with 10 seconds of time. And as you see this happening here, you can see that's a lot of data getting filled in there. We're at 5 million samples, 500,000 samples a second. That's pretty good. Let's hit the stop button. And I'm going to go ahead and hit my zoom button, and I'm going to get zoomed in here, and let's take a look at what we really have. Let's go get in here, zoom tight. And I want you to see we have a very clean pattern. This is awesome. This is a good capture. I'm happy with this. Very good quality here. Let me go ahead and find my other rulers. Let's see. So you can see we're measuring a pattern. It's what, 54 microseconds is our time there. Pretty darn good sample rate for that. Let's go ahead and crank it up. I'm going to go ahead and put 5 seconds on our per division up here. So we're gathering an enormous amount of data here. I'm going to go ahead and turn my cursor off. This buffer is filling up. It's a lot of data. As you see, we're at 5 million samples is what our sample is going to be on the whole buffer. And that brings us to 100,000 samples a second. So I'm going to say here, well, yeah, we've got a lot of time on the screen. We could be running this car for 50 seconds, and let's say we had a little hiccup or something. We can hit the stop button. So we're going to go ahead and hit the zoom button here, and I'm going to go ahead and zoom in and see what this pattern looks like, and see if we still have ourselves a decent pattern. You can start seeing that we're having a little bit of V shape to our wave here. But this would still be good if you had a major glitch. I think you'd still be able to catch it, and that's a boatload of time. I would never really usually have that much time on the screen. Let me go ahead and over-exaggerate this thing for you to show you what it really looks like if we have a bad sample rate. The bad sample rate is where technicians get screwed up all the time. So I'm going to go ahead here, and we're going to go ahead and put this thing up to, say, let's say 50 seconds of division, and I'm going to hit the run button. So 50 seconds of division is just a ridiculous amount of time, and it seems like the scope has got stuck here. Let me hit the stop button, and I'm going to hit run one more time. I think just had a little glitch there. That might just be something on my end. Filling up the scope buffer with data. I'm not going to let this thing run forever. I'm going to hit the stop button. Now let's go ahead and hit the zoom in button. Drag this over to where we want to zoom, and I'm going to put that right in the middle of the reticule, and let's go ahead and hit this bigger and bigger and bigger. What I want you to see here is we've lost all of our resolution. I wouldn't be able to tell you if this was a square wave or what type of wave it was, just based on the fact it looks like a V. When you have a V shape like that, our sampling's off. Now, let me take a look here and see if we can do something. I usually do this with the picoscope when I'm demonstrating in class. Let's turn on our cursor, our time cursor up here. I'm going to drag one of these over here. We're going to play connect the dots because that's what your scope is always doing, right? I want you to see we're at 100 microseconds, 104 microseconds difference there. Let me go ahead and zoom in a little bit more, bring this thing back. I'm going to try and find my other right here. I'm going to make it so I'm just measuring point to point. We're about 100 microseconds, right? That's basically our sample rate. We're at 10,000 samples a second, but we had way too much time on the screen. If you have too much time, you're going to lose your quality. So this is really something I would never do. Like I said, this is way too much time on the screen. Let's go ahead and get this back to something normal. But I just wanted to show you guys that you can actually really overwork the scope, and that's when you lose all your resolution. So turn off my zoom. Always have your zoom off when you go to change your sampling. I'm going to put this, let's say, I think we should be able to go really back to, say, 5 seconds of division, like I said, or let's go to 2 seconds, I'm sorry. 2 seconds of division. We're at 5 million samples, 250,000 samples a second. That is pretty stout, nothing to sneeze at there. Should be just fine for any automotive application. Let me go ahead and zoom in on this. Click on the zoom button. I'll drag this over to the middle and zoom in. So there you go. I'm trying to get it so we have one revolution of the crankshaft there, and let's just go ahead and zoom in real tight and see that we have a nice square wave. That is beautiful. I'm happy with that. You know, when you get really in tight, it's going to start to open up no matter how fast your scope is. So this is, you know, the difference in time between this little slope here is 4.2 microseconds, which is really not that much time, maybe 3 point something odd microseconds. Slow, very fast amount of times. All right, so I gave you a little overview. I want to show you something about the waveforms, reference waveforms. Let's go ahead and use this demonstration board that I can introduce a fault with. This is a fault that is easy to find if you have a math channel that you can run, a frequency math channel, which would actually plot the frequency, or on a snap-on you'd use a graphing multimeter. Unfortunately, I have not found in this tool the way to do that yet, but I do want to share with you basically how you make a reference waveform and also line it up and see what's going on. So in this instance, we've got our scope running here. I want to have, let's say we're capturing a crankshaft signal, and I want to have a couple of revolutions of time on the screen so we can do it. That's probably more than enough right there. Okay, so if I'm just doing a quick crank of a vehicle and I know there's a fault, I'm going to go ahead and hit the stop button. And now I want to show you first of all that we can go ahead and zoom right in here all the way, and we have a very, very clean signal. Okay, we've got a nice clean signal, nothing to worry about there. So I'm going to go ahead and save this. I'm going to first of all, well, I can hit the run button one more time, and I didn't zoom in. See, that's what's interesting. Sometimes this leaves me right where I was. I want to be, let's see, let's where we're at here. I think 100 milliseconds of division is a great place to be. So we can go ahead and hit the stop button, and I'm going to go to menu, and I'm going to hit save, and I'm going to save this as a reference waveform 1, and we're going to call this crank good. So we're going to call it crank good and hit enter. And save to R1 once again. So now we have a reference waveform saved. Now I can hit the run button on a scope again, and we're capturing data, and that's good. I'm going to go ahead and click on the middle of the screen. I'm going to introduce a fault. So right now there's a fault happening. So I'm going to hit the stop button, and I'm going to hit menu. And then anytime we capture a fault, we always want to hit the save button. We're going to call this crank bad. Oops. And I'm going to hit enter. So this is saved. I'm going to save that. So we've got this crank bad signal. Now what we want to do is try and compare the two. Now this is kind of a good because you see the two patterns don't exactly line up. The first thing I'm going to do here is I have reference 1 is on. I'm going to turn reference 1 off. I'm trying to figure out why am I capturing a little bit of purple aliasing here. That's interesting. I'm going to turn that back on. So let's go ahead and take a look and zoom in on our waveform here. And let me zoom out a little bit. I'm trying to get it so we have a missing tooth here. I'm going to click on the channel button down here to choose that I want to mess with my reference waveform over here. And I'm going to go ahead and increase my time to about the same. So you can see here, I can drag this over, kind of line the two up. And as we're doing this, if we just take a look around, you may be able to see a problem right off the bat. Maybe you can see it, maybe you can't. I'll be the first one to tell you that it is right over here. This is the problem. Guys, this is kind of hard to see if you're not looking for it, I won't lie. So if we go ahead and back in here, back and select our channel, we're going to go to channel 1. And if I want to go ahead and make this a little bit bigger, so we can go ahead and kind of see that we scroll through here, and we're scrolling through. There's a hiccup. I put an extra tooth in there, just one extra tooth. I know that's kind of cheating and mean, but this is real life. This is actually a scenario that I found. If you haven't seen it, be sure to check out that Mercedes-Benz crankshaft video on YouTube. But you see we don't have, if we click on our other channel, we do not have that pattern happening. Let me click on R1. We don't have the extra tooth there. Now, when we're on channel reference R1, we can actually increase our scaling and decrease it all that just the same. So I really think it is a very cool feature that this scan tool has the reference waveforms. Very, very good job, Matco, there. I like that. There's also a couple other features and functions you can mess around with. I know I'm leaving a lot of stuff on the table. There's one other menu I should show you real quick here. Just so you know, if you don't know what you're trying to test, you do have this automotive menu here. You can go to circuits, sensors. If you click on crankshaft, it kind of sets the scope up for you how it should be. So I'm going to hit OK. It automatically preset the scope up to this setting. That's where it put it. If we were testing something else under automotive, you got lambda sensors, which is interesting. I wonder how they're going to do that. Okay, so they got titania, zirconia with heater and pre and post. So there's a lot of different things. There's camshaft sensors. airflow meter. Let's see what airflow meter does if we go hotline, or actually maybe digital. Let's hit OK. What does it set it up? I do have an airflow sensor we can set up here. Hang on. I do have my, this is when I teach classes, I got this thing. This thing is a bit glitchy and buggy. I think I have a bad little switch in here. Let's go ahead and hook this up and see what we get out of this. We're just going to go ahead and hook this signal up here. And let me show you, we've got this and that. There we go, we've got this signal hooked up. So as I hook that up, you can see what happened there. This is how the scope preset up at 500 milliseconds per division, which is half a second per division, so we have 5 seconds of time on the screen. I'm going to give this mass airflow sensor a quick and see if it catches it. Let me hit the stop button, and let's go ahead. It's showing us the duty cycle. It shows us what it had done here is pretty cool. It's set up the amplitude, high and low, frequencies for the whole screen, though. That's a problem. I want to see the frequency changing. Let's go ahead and zoom in tight on this and see what happens. And I'm going to scroll through our buffer and see if you can see when I blew on this thing or not. Let me hit the zoom button and go all the way over here. So you can see if I play it back like this, running my finger across there, you can see the frequency increase and decrease as I blew on it. Let me hit the run button again, and I'm going to go ahead and bring down our time. We want to bring this in tighter. And one of the things, just to show you, if I do a real quick blow just like this, I want you to see on the scope how sensitive a mass airflow sensor is. So you can see that this is definitely capturing the change. It does show us the frequency, but it's showing us the frequency over the whole buffer. So the frequency that we see right here is nice and all. I mean, it's nice, and that's how you can get the measurements. If you go back up to the menu here, and I click on measure, you see that these measurements are all listed here. This is how you get to those. Unfortunately, we can't really adjust and see the frequency high and low. I don't think so. It says we have frequency, but I don't see the high and the low. It's all voltage. I want to see the frequency high and low listed, but all we have is frequency. So if we go ahead and make a smaller buffer, let me go ahead and X out of this. Let's make this kind of small like this. Watch the frequency on the scan tool as I blow on it. You can see the frequency change on the measurement there, but if we have a lot of time, they had us set up like time like this. The frequency doesn't really mean much. When we have this much time on our frequency, it just doesn't matter because the frequency is going to stay the same. So if you watch here, if I just go like this, the frequency never changes on the scan tool. I don't think it ever changes. It might change in the buffer just slightly, but you're not going to be able to capture it like that, which is kind of, it's interesting. So there's quite a few options and buttons on a scan tool. The only other thing that I can think of to share with you that is probably worthwhile noting is it does have math channels. So I think we should take this thing outside, hook it up to a one of my vehicles, and check CAN bus. Or maybe on the tool itself, on the upper right hand corner, we got that drop down. There is the math channel button here, and if you click on it, you can see here that we do have a bunch of different options. We can choose which channel we want as an input, and then what do we want to do with it. Do we want to add, subtract, multiply, divide? And it makes a math channel with the other channel you select. So you could go channel A or channel 1 minus 2, channel 1 plus 2. That's kind of what you can do there. But unfortunately, I don't see a math channel for frequency. Now on this list, as I said, we're going to take a look at the CAN stuff or whatnot. There are bus decoding, I believe. We will see what we can do to make this decent, but you can click on CAN and choose what channel, CAN high, CAN low. You can select your baud rate. And I believe it already set the scope up. As you see, it's trying to set the scope up just for that. I'm going to go ahead and turn off all these measurements. And I think we should go ahead and hook up a demonstration board with CAN. All right, everyone, we are set up on a real vehicle here. We've got our channel 1 is going to go into our pin 6 of our DLC. That is CAN high. And channel 2 is going into pin 14 of our DLC. That is CAN low. So I'm going to go ahead and turn the key on here There we go. And we've got ourselves our scope on. All right, I'm going to go ahead and hit the run button. You see we've got a capture going on. I'm going to turn on channel 2. And let's go ahead and take a look at what we have. If we stop this and just go ahead and hit the zoom in button, we'll hit zoom. And let's go ahead and make this tighter. You can see we have some nice cam packets here. I'm going to go ahead and adjust the channels here. I want my channel 1 to be a little bit higher, and I want my channel 2 to be a little bit lower. And I'm sure you guys can tell even so far that just messing around with the scope a little bit, I'm getting a little more comfortable with it, which is awesome. So I'm going to hit the run button again. So let me go ahead and hit the stop button. And once again, I meant to hit zoom in. Get over here, take a look. Let's get tight. Let's get real tight and see, can we see what we have here? So you can see we don't have enough sample rate. Our sample rate's on the low side here. So we have to increase our sample rate. And to increase our sample rate, we have to put less time on the screen. So I'm going to hit the zoom out button and go ahead and hit the run. And we're going to go ahead and let's go ahead and put this down to, say, 50 microseconds of division. Right here. Now I want to trigger this event. I want to have this triggered because you see we have a lot of time that nothing's happening on here. I'm going to hit the channel 1. We're going to go to our menu and go to our trigger. We're going to trigger off channel 1. We're going to go ahead and do a rising edge count on channel 1 and hit OK. And then I'm going to bring my level up to the point where it's on the scope. And I'm going to go ahead and drag this over so we can capture that. So we have good CAN bus activity. That is what it looks like. If I hit the stop button, you're going to see there's nothing to zoom into. We don't really have a whole lot to zoom into here. So I'm going to hit the zoom button again. And let's see how much time we can put on the screen before we get a bad signal. Let's go ahead and put this to 100 microseconds per division. So let's go ahead and run that. So we still have a good pattern, I think. Let's crank it up a little bit more. Put some more. Let's go 500 and hit the stop button. Let's see what that looks like when we zoom in here. We still have decent CAN bus pattern. That's a pretty good capture for the amount of data that we have captured on the screen. We only have a couple of messages here. I'm going to go ahead and start this vehicle because I think more stuff will communicate with it running. Let me go ahead and start it up. The key was on, but I've noticed on this car I get a lot more information, or should I say messages. I've messed with this car a lot. And I get a lot more messages when it's running. So there we go. Let's go ahead and put some more time on the screen. How more can we go? We can go 1 millisecond in division, and you know, we can actually, let's go up to 5 milliseconds of division and see what that looks like. Let's hit the stop button and we'll go ahead and zoom in, and we're going to see if we have anything useful if we actually had to take a look at the data. Let's go ahead and get zoomed in here tight. I'm going to scroll back until I find it. Oh, that's beautiful. That's nice. That is nice. We have a lot of decent capture here. I'm going to zoom back out. 5 milliseconds is a little bit on the high side. We'll go back to, let's say, 2. I'm going to hit the run button. One thing I want to check out here is on the left-hand side, we have this S1 and S2. Let's click on this. We're going to go for S1 is going to be CAN. Channel 1, CAN high. 500 kbaud, and I'm trying to see if we can decode a message, and that's one thing I haven't been able to figure out yet. I'll turn that back on. There we go. So you see something going on there. Let me hit the stop button and we'll zoom back out, and we caught nothing here. We've messed our trigger, so I'm going to zoom back out a bunch. I'm going to hit the run button. Let me zoom back out to get a lot of stuff on here until my trigger comes back into the window. My trigger is off the window in the upper left hand corner. You can see it's not even there. I want out of the zoom menu. That's the thing, I was stuck in the zoom. There we go. We've got this decoding some data here, so that's pretty cool. Let's see how far out we can go. We can't go out past that point, but I need to get my trigger. Guys, I gotta grab my trigger. Here's my trigger. I'm gonna put it back into the close to the middle of the screen here. And let me hit the stop button and see if we zoom in now. Check this out. I think we've actually got something. Let's hit the zoom button, go over to our data packet, and you can see we have a bunch of question marks. Oh, there are some question marks, I thought. So it looks like you can decode with this. That's impressive. You know, I'm not saying you're going to always be doing that or it's an everyday thing, I just want to see if it can decode. I'm trying to get better at it, so if I have to work with somebody that asks about it, I can help them out, and you guys get to see me learning. Not quite as I'm earning, not getting paid for this one, right? Let's go back down to 500 microseconds. And I want this trigger. I'm not happy with my level here. Gotta go back to this screen. So my trigger level menu had disappeared. Where did it go? So we're on a trigger for this. I'm trying to trigger off of, I guess, this CAN data. Let's go ahead and go common. And we're gonna go to edge, channel 1. So we're gonna trigger there. Now I got this level, so I can bring this up. Let's get this off here so we can bring our, there we go. So now we can actually see some data packets going through, and that's cool. So it took me a little bit of time to get here, but I'm going to go ahead and you got to kind of have this trigger back to the beginning, if you will, to be able to access it. And there you can see the data packets run through, but we can always have something here. I saw a couple errors pop through and I see these question marks, but if I hit the stop button, what happens if we zoom in here where we have this question mark? I want to really see. Put this in the middle, hit the zoom, and where do we have these question marks? I thought I saw something, but maybe, oh, there's a question mark. So something in there is making some noise, I think, that the scope doesn't like. See, it has a question mark here, and if I drag it towards the middle, it's still a question mark. Oh, now it isn't a question mark. That's interesting. So maybe it's because it's off the screen. Quite a bit to talk about here and play with, but that is live data, and you can see we can actually decode CAN with it. Well, guys, there you have it. If you like this content, do like, subscribe, hit that notification bell, give me a thumbs up. Overall, the tool's pretty cool. I don't like the fact that it doesn't have the frequency math channel or a way to graph frequency. That's kind of a bummer there. We're lacking on that aspect of it. But overall, it's a pretty powerful tool. I'm going to continue to play with it before I give it back on Monday. You guys have a great day. Thanks a lot for watching. Bye-bye.